Hello everyone, welcome to Talk Mathematics. So this is the fifth video of doing class 11 NCERT solutions of chapter 1 sets, and today we will be doing exercise 1.4. So some of the basics that are required first are Venn diagrams. So Venn diagrams are the diagrams which we use to represent the sets to solve questions. So firstly we consider a set U like this. It has some elements 1, 2, 3, 4, 5, 6 and 7. So set U contains elements numbers like 1, 2, 3, 4, 5, 6 and 7. So then we construct another set A. Suppose I construct this as A. Now A has only 3 elements, which is 3, 4 and 5. So from this we get that U, the bigger set, is called universal set, which contains all other sets. We can construct one more set like this, green color one, B. So we know that B contains only one element, which is 3. So universal set is the bigger set. Then we have another sets inside U. So from this we can get that B is a subset of A because B is inside exactly A, and A is further the subset of U, which is the universal set. Next up is union of sets. So suppose we have a set A which has elements 1, 2 and 3. So it will be represented using Venn diagram. Like this is set A, it contains 1, 2 and 3. Then we have another set B which contains elements like 10, 11, 12. Okay, so B will be something like this, and it contains 10, 11 and 12. Now A union B is a function which contains all the elements of A as well as B, both the elements. So A union B will be, if we see from here, this will be universal set U, the bigger one, and we have set A here and B here. So a set which contains all the elements of A as well as B is union set, and if we have to shade it, the region would be this, which contains A elements also and B also. So A union B will have elements 1, 2, 3, 10, 11 and 12. Next we have some properties of union function which we studied. So the first property is that A union B is equal to B union A, which is the commutative law. The second one is associative law, which says that A union of the whole union B union C is equal to A union B with union C. The third one is law of identity, which says that A union phi is always equal to A. You know that phi is an empty set. It does not have any element in it, and A. So A union phi, all the elements of A as well as phi will always give A. The fourth property is idempotent law, which A union with A will be also equal to A. All the elements of A as well as A together, it will be only A set. The fifth is law of universal set, which says that A union with the universal set U will always be equal to the universal set for the U. Suppose this is the universal set U, A will be something inside it. So all the elements of A and all the elements of universal set. So when we combine it, the area will be this, and it will be universal set U. Next is intersection of sets. So intersection is denoted by this, opposite of union. It means we have to state the common elements only. So suppose we have a set A which has 1, 2, 3, 4 and 5, and then again we have a set B which has elements 1, 3. So A intersection B, here common elements. So 1 is present here also and here also. So 1 will be here. Then 2 is here present in A but not in B. 3 is also present in both. So the common elements are only 1 and 3. So denoting it by Venn diagram, suppose we have this set A, it will be like we have set 1, then 2, then 3, 4 and 5. Then there will be a set B. This is set B. B will contain 1 and 3. So A and B intersection is denoted by this. This is the shaded area. This shaded area is of intersection, that means common part. Next, some of the properties of intersection. So the first one is commutative, that A intersection B is equal to B intersection A. The second one is associative. A intersection B with intersection C is always equal to A intersection B intersection C. The third is law of identity. A intersection with phi is always equal to phi, where phi is an empty set. So we have to find the common elements which are present in phi also and A also. But we cannot find any common element because phi has no element. So the whole answer will be phi, which is empty. The fourth is idempotent law, which says that A intersection with A will be always equal to A. The common elements in A and another set A will be A only. The fifth is law of universal, which says that A intersection with the universal set. So let us see through a Venn diagram. If the bigger one is U, the universal set, and we have a A inside it. So the common elements present in U as well as A, you can shade the region, it will be this only. This area will contain A also, elements of A also, as well as the elements of U which are common. So the answer will be A. Next we will talk about the difference of sets. So if we have a set A which is 1, 2, 3, 4, 5 and 6. We have a set B which is 2 and 3. So difference means you have to just minus them. Okay. So A minus B will be equal to, from the set A you minus or remove the set 2, and from A you remove the element 3. So we will get only 1, 4, 5 and 6. This is the difference of sets. So A minus B will be, if we want to show it through Venn diagram, this is the U set, universal set, and this is A set and this is B set. Okay. So from A you have to minus the B, you have to remove B. So what we will left with? We will left with only this part, and this is A minus B. Also one more, A minus B is not equal to B minus A. Okay. So we are done with the basics. Now let us come to the examples of exercise 1.4. So example 12 says that A is a set which contains this elements, B is a set with this. We have to find A union B. A union B means we have to write all the elements of A as well as B. So first of all let us write elements of A, 2, 4, 6 and 8. Now we will write the elements of B. B has 6 but 6 we have already written, so we will not repeat it. 8 also we have written. Then we have 10 and 12. So this set is union set. Example 13 is we have A with this, B with this. Show that A union B is equal to A. So let us first construct what will be A union B. It will contain all the elements of A as well as B. So writing elements of A, E, I, O, U. Then we have to write the elements of B. B has A. A we have already written, and you know the property of sets that we not repeat elements inside a set. I we have already written, U also we have already written. So this is the set which is A union B. And when you will match that, A union B will be equal to the set A. Example 14 says that set X contains Ram, Geeta and Akbar, set of students of class 11 who are in school hockey team. Y contains Geeta, David and Ashok, be the set of students from class 11 who are in the football team. X union Y. X union Y contains the elements of X. X contains Ram, Geeta, Akbar. Then we have to mention the Y elements. Geeta, but Geeta is already present, so we will not repeat it. Then we have David, and then at last we have Ashok. So this is the set of X union. Example 15 is consider the sets A and B from example 12. So from 12 A was 2, 4, 6 and 8, and B was 6, 8, 10 and 12. So finding A intersection B, that means we have to find the common elements in A and B. So the common elements I could see only 6 and 8. Example 16 is consider the sets X and Y from example 14. So X was Ram, Geeta, Akbar. Set Y was Geeta, David and Ashok. So X intersection Y, the common element in both is only Geeta. Example 17 is we have a set A and B. We have to find A intersection B and hence show that A intersection B is equal to B. So we have to find the common elements. So the elements which are in both A and B, I could see it is 2 which is present in both. Then we have 3 which is present in both. 5 is also present in both and 7. So A intersection B will be 2, 3, 5, 7, which is nothing but the set B. So example 18 is we have a set A and B. We have to find A minus B. So A minus B means we have to remove the elements of B which are present in A. So B has element 2, so we have to remove 2 from A. Then B has element 4, we have to remove 4 from A. Then B has element 6, we have to remove 6 from A. Then B has element 8, but 8 is not present already here, so how to remove it? So A minus B will be 1, 3 and 5. Okay. So then next we have B minus A. B minus A says that from B we have to remove the elements of A. So A has 1, 1 is not present in B. A has 2, we have to remove 2 from B. A has 3, we have to remove 3 here, but 3 is already not present. We have to remove then 4, then 5, then we have to remove 6. That's it. So B minus A will be 8. So from here you can make a result that A minus B is not equal to B minus A. Always. Example 19 says that this is V and this is B. Find V minus B and B minus V. So first of all V minus B will be, we have to remove the elements of B from V. So B has A, we have to remove A. Then it has I, we have to remove I. K, we have to remove K from here, but it is not present, we have to remove U from here. So we get E and O. Next is B minus V. V has A, we have to remove A. It has I, we have to remove I. It has E, we have to remove E. O, we have to remove U, we have to remove. So B minus V will be K. So we are done with the basics and example. So let us begin with exercise 1.4, first question. So we have to find the union of each of the following pairs. So the first part is X and Y, we have this. So X union Y will be equal to all the elements of X, 1, 3, 5 and Y. 1 we have already written, then it's 2 and then 3 also we have written. A and B, so A union B will be all the elements of A as well as B, A, E, I, O and U. Then A we have written, B and then C. Then third part is A is natural number and a multiple of 3. So the natural number multiple of 3 are 3, 6, 9, 12 and so on. B is a natural number less than 6. So less than 6 means natural number, it is 1, 2, 3, 4, 5. Right? So A union B will be equal to 1, 2, 3, 4, 5, then 6, then after 6 it will be 9 and 12 and then so on. The set will go on and on. Fourth is X is a natural number between 1 and 6, so it will be 1 is not included. So natural number will be begin from 2, 3, 4, 5 and 6 because 6 is included. B is a natural number between 6 and 10. 6 is not including and 10 also. So it will be 7, 8 and 9. Now A union B will be the common all the elements of A as well as B. So it will be 2, 3, 4, 5, 6, 7, 8 and 9. Fifth is A is 1, 2, 3 and B is empty set. So all the elements of A and B, A union B will be 1, 2 and 3. Second question says that A is this and B is a set this. Is A a subset of B? A is A and B. So all elements of A are present in B. Right? So yes, A is a subset of B. Then we have to find what is A union B. A union B is all the elements of A. Then B, we have C left. So A, B, C. So A union B is nothing but the set B. Question 3 is, if A and B are two sets such that A is a subset of B, then what is A union B? So let us solve this using an example. So let us consider A, which contains suppose 1 and 2. And we consider B, which is 1, 2, 3 and 4. So clearly A is a subset of B because all the elements of A are present in B. So when we'll calculate A union B, all the elements of A as well as B, so we get 1, 2, 3 and 4, which is nothing but the set B. So the answer to this question is that A union B is equal to B if A is a subset of B. Now next, let us consider fourth question, which is we have a set A and B, C, D. We have to find A union B. So for the first part, A union B will be all the elements of A, and then B, 3 we have already written, 4 also written, left with 5 and 6. Second is A union C. Elements of A, C is 5, 6, 7 and 8. Third part is B union C. All the elements of B, 3, 4, 5, 6 and C. C contains 5 which we have written, 6 written, then 7 and 8. Fourth part is B union D. B, all the elements of B, 3, 4, 5, 6 and then D, 7, 8, 9 and 10. Fifth part, A union B union C. All the elements of A, 1, 2, 3, 4. All the elements of B, 3 and 4 we have written, 5, 6. C elements, 5 written, 6 written and we have left with 7 and 8. Sixth part is A union B union D. 1, 2, 3, 4. B has elements 3, 4 written, 5 and 6. D has elements 7, 8, 9 and 10. Seventh is B union C union D. All the elements of B, 3, 4, 5, 6. 5 and 6 we have written, then we have 7, 8. For D, 7, 8 we have written, then we have 9 and 10. Now we need to find the intersection X intersection Y. We have to find the common elements. So common element is only 1 also and 3 also, which is present in both X and Y. So intersection will be 1 and 3. intersection of A and B will be, the common elements are A, only A. So A intersection B will be A. A intersection B, here x is a natural number and multiple of 3. So it is 3, 6, 9, 12 and so on. This set is natural number less than 6, 1, 2, 3, 4, 5. So A intersection B, common elements. You can see from here 3 is present in both, only 3. So A intersection B will be 3. Fourth part is A is natural number 2, 3, 4, 5 and 6. B is 7, 8, 9. So A intersection B is the common elements. There is nothing common here, so it is 5. Fifth part is 1, 2, 3 and 5. So intersection, what is common here? So there is nothing common here, so it is 5. So sixth and first part is A intersection B. The common elements in A and B are 7 is present in both. We can see 9 is also present in both and 11 also. Second is common elements of B and C. We could see only 11 is present and 13 also present in both. Third part is the common elements of A as well as C and D. So A, C and D. 11 is present in A, present in C, but it is not present in D. So there is nothing common, so third part is 5. Fourth part is common elements of A and C. So there is only one element, which is 11. Fifth part is common elements of B and D. So we cannot find any common elements, so it is empty. Let us come to the sixth part. It says A intersection B union C. So first of all, let us write B union C. B union C is all the elements of B as well as C. C has 11, which is written, 13 which is written, and then 15. Then we have to find the common elements of A and this set. Common elements here are 7 is common, 9 is common and 11 is common. Then we have seventh part, the common elements of A and D. Nothing is common, so it is empty. Then eighth part is we have to find A intersection, then B union D. B union D, let us write here all the elements of B, 7, 9, 11, 13 and D, 15, 17. We have to see its common elements in A and this set. The common elements are 7, 9 and 11. Then for ninth part, it is, first of all we have to find the A intersection B. So let us write the common elements of A and B. So common elements are 7, 9 and 11. Then we have to do the intersection with, we have to find the union of B union C. All the elements of B as well as C. So let us write here all the elements of B, 7, 9, 11, 13 and then C, 11, 13 already written, then we have 15 left. Now between these two sets we have to find the intersection, means common part. So common here is 7, 9 and 11. Lastly we have 10th part, which says that firstly we have to find A union D. All the elements of A, which is 3, 5, 7, 9, 11. All the elements of D, 15, 17. Then we have intersection with, now we have to write the elements of B union C. All the elements of B, 7, 9, 11, 13 and then C, 11, 13 already written, then 15. Now we have to find the common elements in these two sets. So we could see the common elements are 7, 9, 11 and 15. So next we have question 7. So for question 7, let us first of all state what are these sets. So A is a set of natural number. So it is like 1, 2, 3, 4 and so on. Then B is a even natural number. So it is 2, 4, 6, 8 and so on. Then C is an odd natural number. So it is 1, 3, 5, 7 and so on. D is a prime number. So it is 2, 3, then 5, 7 and so on. First part says that we have to find the common elements of A and B. So the common elements are 2, 4, 6, 8 and so on. So what is this set? This is set nothing but the set B. Then second we have to find the common elements of A and C. So for common elements A and C it is 1, then we have 3, 5 and 7 like this. So this is nothing but the set C. So you can see from here that A intersection B is coming B and A intersection C is coming C. Also A intersection D will be nothing but the set D. So the reason for this is because A is the bigger set and B is a subset of A. C is also a subset of A and D is also a subset of A. So we have done this property, so this will be D. Then we have intersection of B and C. So you can see there is nothing common in B and C. So fourth part will be empty. Nothing is common here. Then we have to find the common elements of B and D. So the common elements are 2. Then except 2 nothing will be there because D is a prime number and B is an even number. So we have only one prime number which is even, which is 2. So for fifth part the answer will be only one element which is 2. Sixth part we have to find the common elements of C and D. So common elements of C and D will be 3, then 5, then 7 and so on. All the odd numbers which are prime, it will be like this. So eighth question says that which of the following pairs of sets are disjoint? Disjoint means nothing is common. Nothing in common means A intersection B will be 5. Nothing in common. So for first part we have 1, 2, 3, 4 and X is a natural number between 4 and 6. So this set is 4, 5 and 6 and this is 1, 2, 3, 4. So we could see the common element is 4. So this is not disjoint because it is as common element which is 4. 4 is common here. Second part is this set and this. Is there anything common? No, there is nothing common. So yes, it is disjoint. Third part is X is an even integer and X is an odd integer. So we know that even integer, odd integer, nothing would be common. So yes, it would be disjoint. 9 says that this is A set B, C and D. We have to find all these. So the first part is A minus B. From A we have to remove the elements of B. So it will be, we have to remove 4, we have to remove 8, 12, 16 and 20. So we will be left with 3, 6, 9, 15, 18 and 21. Second is A minus C. From A we have to remove C. So we have to remove 2 from here, 4, we have to remove 6, then 8, 10, we have to remove 12, 14 and then 16. So we will left with 3, 9, 15, 18 and 21. Third part says we have to remove the D from A. So by first removing D. 5 we have to remove 10, 15 and then 20. So only one element is removed. So it is 3, 6, 9, 12, 15 is removed, 18 and 21. Fourth is remove A from B. So from B we have to remove the A. We have to remove 3, 6, 9, we have to remove 12, then 18, 21. So only one element is removed which is 12. Fifth part is remove A from C. So we have to remove from here 3, we have to remove 6, we have to remove 9, 12, 15, 18 and 21. So we are left with 2, 4, 8, 10, 14 and 16. Sixth part is remove A from D. So we have to remove 3, 6, 9, 12, 15 and 18. So we are left with 5, 10 and 20. Seventh part is remove C from B. So from B we have to remove 2, 4, 6, 8, 12, 16 also. So we are left with only one element, 20. Eighth part says we have to remove D from B. So remove D From B we have to remove 5, 10, 15 and 20. So only 20 is removed. So we are left with 4, 8, 12 and 16. Then let us come to ninth part, which says remove B from C. So from C we have to remove the B, we have to remove 4, we have to remove 8, we have to remove 12, 16, 20 is not present here. So ninth part we have 2, 6, 10 and 14. 10th part says remove B from D. So we have to remove 4, 8, 12, 16 and 20. Only 20 is removed. So we're left with 5, 10 and 15. 11th is C minus D. Remove D from C. So from C you have to remove D part. We have to remove 5, 10, 15 and 20. So we are left with 2, 4, 6, 8, 12, 14 and 16. 12th part is remove C from D. So we have to remove 2, 4, 6, 8 and 10. That's it. So we are left with 5, 15, 20. Now we have 10th part, which is x is defined like this and y like this, x minus y. You have to remove the y elements which are present in x. So remove f, you remove b, you remove d and g. So we are left with only a and c. Now remove x elements from y. So we have to remove a, b, c and d from y. So we are left with f and g. What is the intersection of a and b? A, x and y. Intersection is b and d. If R is the set of real numbers and Q is the set of rational numbers, then what is R minus Q? So from real numbers you have to remove all the rational numbers. So what we are left with? We are left with irrational numbers, which are denoted by Q dash or QC. State whether which of the following statement is true or false and justify your answer. First part is this set and this set are disjoint. Okay, so we can say that they are disjoint when their intersection is empty. So can you find any intersection element? Yes, 3 is present here. So these are not disjoint. So this statement is false. Second part is can you find any common elements? Yes, we can see A is common. So these are not disjoint. So this is false. Now can you find any common? No, we cannot find. That means yes, their intersection is empty, means yes, they are disjoint. Next is, can you find any common elements? No, so that means it is true, they are disjoint. So that's all for the exercise 1.4 of this chapter 1 sets. We will be doing next exercise in the next video.